Hey guys, we are on GCSE Trigonometry Revision and we are going to consider circles involving trigonometry. So probably you remember about inscribed angles, so how they connected with the central angles. That's all features about circles, so make sure you remember all that. And also like how the radius, which angle it range to the tangent line, so that's also a key feature here. Okay, and try to do by round, pause the video, try to work out your answer, try to compare with mine then. And we start doing this. I'm going to the next slide where we have already a sketch of the picture corresponding to the problems. And let's have a look. So we have a tangent from a point M, it's right there, to a circle with a radius of 6. So we got the parameter of the circle, which is 6, and it's 15 meters long. Okay, we've got that MN is going to be 15 meters long. Okay, so that's the segment MN. So N is going to be the touching point, so touch the circle and point N. So one more time about the tangent line. So the tangent line is the line that have one common point with a circle. So what about the circle? As you remember, as any curve is LOCI, so loci, or set of points arranged in such manner so that the distance from any random point of those loci to the center is going to be the same, and is going to be the radius. So radius is the key parameter of the circle. Radius defines their set of points, and so make sure you probably remember the equation of the circle, which centered in the origin x squared plus y squared equals r squared. So that's algebraic equation for this LOCI. Okay, now so about we come back to the statement. So we need to find the distance of M from the center of the circle. So distance of M from the center. All right, center point M, we need to find that distance, so I mark up as x, and we have to define the MO length in this case. And we also need to find the size of the angle between the radius that goes from the center to the point N. All right, so I use the red color and connect the center to the point M, to the point, N, and that's going to be the radius, which is 6 meters according to conditions. Okay, and we need to define the angle between this radius and the line segment MO. So we need to define this angle. Let's set up as theta. Theta is also need to be defined. And let's have speculate there. All right, we have, what sort of triangle we have? Definitely triangle MNO is going to be right angled. So right angled. Why? Make sure you remember, I told you that make sure you remember the properties of the tangent line segment and the radius. So in one common point where they meet, they arrange an angle of 90 degrees or right angle. So this angle is going to be 90 degrees. That's by definition. All right, so we have right angle triangle, and we just simply can apply trigonometric ratio in order to define, let's say first, hypotenuse. In this case, x is hypotenuse, it's opposed to 90 degrees angle, and we have also adjacent side and opposite side. Okay, there are plenty of ways in this case to define, so it seems to me that we have extra more data in this problem. So we can arrange using Pythagoras, we can arrange using trig ratios, so we're going to use trig ratios. Oh no, we cannot do because we don't know theta. All right, yeah, so the first step is to apply Pythagoras. Okay, so Pythagoras basically connect all three sides, and that's why x squared is going to be 15 squared plus 6 squared. That's what Pythagoras tells us. Okay, so we've got 225 plus 36 and square root of that. That normally we calculate, and let's do this. Okay, so the answer is 16.16 meters, 2 dp. All right, so that's the answer for MO. In this case, we find MO in meters, and that's our solution for a mark as red. Okay, and this is our solution for MO. It's going to be 16.6 meters. All right, we'll go next, and the next part is to define angle theta. So which way we can do? We can use several ways of determining theta. So what's best for you? As you remember, I told you if you have initially given sides so that you can arrange some trigonometric ratio, that will be the perfect and ideal case in order to define theta, because no rounding involved. In this case, you're taking initial values. All right, so that's why we can arrange tangent rule. So tangent theta is opposite 15 to adjacent 6. So we've got 15 over 6, and from where we can calculate inverse trig function from the fraction 15 over 6. So let's say, and let's see what calculator gives us. We've got 10 minus 1, 15 over 6, and 10 minus 1, 15 over 6, one more time. And we've got 68.20 if you round up to 2 decimal place again. Okay, so that's the solution for tangent and for angle itself. Okay, and we've got MO equals 16.60 meters. It's also the length of the segment MO. So hopefully you like that. Hopefully you did the same, because all the previous actually practice should be involved, and right now you are definitely higher level if you watch all the revision and if you couldn't do it before. Okay, so that's the solution, so make sure you got the same. So that was Daniel Dallas, and let's go to the problem 8 soon.